Hello, am I
Yes,
audible?
you are.
Okay, fine.
Yes, you are.
Should have solved this. Missed the solution beyond the. Okay, just a second. Okay, I. Oh, come on. Okay, maybe this one. Oh man, where's the code? I did submit this. Yeah. Where's the code? Yeah, there's the code. Okay, so in the Pascal triangle question, so there are two questions. Okay, so the one is Pascal triangle 2 and another one is Pascal triangle 1. So the question says is we have it can be calculated by summing up the two numbers in the top row and then we'll achieve the bottom row via that. So the difference is of the space complexity. Okay, so in the Pascal triangle 2 problem, what we need to do is we need to solve it in O of k extra space. So if we move on to the to our to whiteboard over here, this is the Pascal triangle, and we can calculate. Suppose we are on this row, all right, and we need to calculate the bot. And I'm referring to this row, what we are at current row as top row, and this is the bottom row which we need to generate. Okay, so this is the bottom row. Okay, so how will we generate is we will add 3 and 1. So we will be adding 3 and 1 to achieve the 4 to. Okay, then we will store over here. Then we will add 3 and 3 for, and the resulting number will be 6. And we'll be adding 1 and 3 for the resulting number to be 4. And then we'll simply copy 1 and add additional 1 over here. So the entire process was basically basically taking a current value that is 1, and adding it to the previous value and ultimately storing it in a separate space. Okay, so yeah, so we are storing it in a separate space. So what we can say over here, the generalized formula to do it can be, suppose space is equal to current value plus previous value. Okay, so the current value, okay, if you remove this, so the current value over here is this one. This is the current value, and this one is the previous value, and we are storing it in a separate space, that is over here, that is space. Now why this is taking O of n square is because we have one particular row. This is the top row, okay, and we are storing the next row in a different space. So suppose we have the first row and we have then we generate the second row in another space, then we generate the third row in another space, and so on. So with that, if we calculate the if the space complexity, the space complexity would be space complexity. This takes one space. This row takes two space. This row takes three space, four space, and five space, and so on till we achieve the desired row. That is probably n. Okay, and nth row, or maybe let's take it as k row, and with the sum of rows, sum of 1 plus 2 plus 3 plus 4 plus 5 to k is basically n into n plus 1 by 2, which gives us n square. So that's the, what we can say is, so the space complexity for this approach will be k square. Hence this is not accept, I mean, as per the Pascal's triangle 2 question, this is not acceptable. We need to do it in O of k space only. Now if we analyze why we are doing so, why it is k square, is because we are storing the result in a different space. All right, so that's a particular hint. If we want to make k square into k space, then what we need to do is we need to remove all the other extra spaces, and we need to store within the array. All right, so what we need, the only thing which need to change is over here is current. So instead of storing the result in a separate space, we can do is we can store the result in the place itself. So we'll be doing in place operation, in place changing. Let's look at how we will do if we have one row. Suppose we have this row. Okay, suppose we have this row, and we come over here. Okay, come on. And the formula for this particular question becomes over here. Do this. So this is the first formula which we're going to do that. And okay, another is, let's take over here, and let's make two pointers. So the first pointer will, since we started from the rightmost position, over here we'll also start from the rightmost position. So we will be having our current pointer, and we will be having our previous pointer, because that's how we achieve the sum. So all we need to do is we need to store current plus previous into current itself. Let's look at over here. So if we change this value, So at this point of time, the current value is 1. So I'm going to write it 1. And the previous value is 3. Okay. And in between, I'll insert a plus sign just to make it clear. Okay. And over here we have equal to sign and equal to sign. Then finally we are doing okay. So we are finally achieving the value as 4. So what we did is the current value is 1 and the previous value previous to the current value is 3. Hence we summed it up and we attained 4. Now we need to replace the current value with the updated value. So what we will do is over here we'll update the value to 4. Okay, now we move on to the next position, that is we'll move our pointer towards the previous once decrement the pointers. So the new value which comes as the current value is we have is 3 and the previous value still remains 3 and then the sum becomes 6. Okay, so we'll be storing current value, the new current value becomes 6. So we store over here 6, update the value, then after doing the operation we'll move our pointers one step back and then we'll do the same step again. Our current value is 3, our previous value is 1 and the resultant sum will be 4. So we'll be replacing the current value, that is 3, with 4 and hence will 4. Hence we obtain this. Now the leftover part is to, if we observe, sorry, okay, actually, okay, so the leftover part is right over here. What we need to achieve is, now all is left is to insert a 1 at the end. Okay, so when we do that when we reach out to the 0th index. So this is the 0th index and when we reach out to that we have to, when the current value is current pointer is pointing to the 0th index, we have to just add an additional 1 at the end, that is over here. So this way the one row is getting converted to the top row is converting to the bottom row in place by changing the value in place. Let's see how we will be doing that. If we have a, now this example was showing when we want to convert from this row to this row. Okay, so if we have the very beginning, how will we able to achieve the desired row? Okay, so let's use the same formula, and the next rule which we need to do is, if the index is equal to 0, then stop and uh, stop and insert 1 at the end. Okay, so that's the second rule which we have. So the first rule is this one and the second rule is this one. Okay, so I'll be quickly going through the, if we have the first array, first row, how will we achieving the kth row? Okay, suppose we have our, suppose initially we need to have this particular row, that is the first row. With this row we'll be generating the next rows. Okay, so if we have this, what we can do is we must have some pointers. Where are the pointers? Let's bring them here. Hmm. Okay, so we have this, and this is the 0th index. This, and we'll be starting from here. Okay, so as per the rule, as per the above mentioned rule, what we need to do is whenever we achieve, whenever the current pointer is pointing towards the 0th index, then we'll stop and insert 1 at the end. Hence, over here, we'll simply insert 1 at the end. Okay, now for the time being, just assume this is not for the first row, it's 0. And okay, let's start from the beginning itself. And we have, okay, suppose I is equal to 0 at this point of time. I is equal to 0 at this point of time, and we will keep the I pointer over here, which just denotes at which row are we present currently. It's not moving. Okay, and what we need to achieve is we need to achieve k is equal to 3, that is the third row. Now let's do this over here. So the first, but at the very beginning when I is equal to 0, the first rule applies, and what we need to do is, since the current pointer is pointing to 0th index, then we insert 1 at the end. Hence what we do is simply insert 1 at the very end. Okay, fine. Next step, we move from left to right. We're moving from left to right, and the current pointer is pointing towards 1. Hence over here, this the second rule applies, and the current position is 1 and the previous position is 1, and hence the sum turns out to be 2. Hence we'll replace the current value with the new value, that is 2, and after that we'll move pointers. And since we are at the 0th index, we'll simply, the first rule applies again, and we'll insert 1. Okay, now since our loop is ended, I mean the steps are over, then it'll start again from right. And with this, again the current position is 1, it's pointing towards 1 index, and it's pointing towards 1 value, and the previous pointer has the value 2. The sum value turns out to be 3. So we'll be replacing the current value with 3, and okay, I didn't update the okay, so the ith value was going on, just a second, okay, so at this point of time the ith value is 3. Okay, let's just start with the 2. Okay, so if the I value is 2, that means we are generating the second row. Yeah, we have generated the second row, and we are moving on to the third row. So the third row, the I becomes 3, and in the third row the pointers are in such a way that we will be let makes k equals to 4. This is the third row at the moment. Yeah, so this is I, and we have the third row at right now. We need to generate the fourth row, hence we increment the value to 4. Now what we do is we replace the current with the updated value. Then what we do is we move our pointers towards left, one step behind. Why is it not moving? Then we do the same thing. We just the current value is 1, the previous value is 1, and the sum turns out to be 3 again. Hence we'll be updating the value with 3, and then we'll be moving our pointers towards the left, and the pointers will be pointing towards the current pointer will point towards the 0th index. Hence the first rule applies, and we'll insert 1 at the end. So that's how we achieve the fourth row, just incrementing I and following these two rules. Let's look at the code. Using these two rules we can solve the problem. And okay, okay, so the where's the so these were the two rules. Okay, so these were the two rules. The first rule is, first of all, what we initially needed to do is we need to insert a 1 for the first row. Then over here we are moving from the rightmost position towards the left position, and at each position what we're doing is we are replacing the current value, that is this one, with current plus previous one, and we are updating it in place. So this particular is the current row what we are storing it in a vector v. Okay, so we are updating the current value with current plus previous, and we are moving from right to left, and as soon as we reach towards the 0th index, we stop, we come out of the loop, and we push 1 in the vector. That's the first rule. So that's all about it. And since following this particular step only generates the next bottom row which we need, so we need to run the loop for uh, 1 to whatever row we need to achieve. Like over here we kept the pointer, we kept the variable I to generate the next row, so we will be doing that over here. Now as always this will run. Okay, so it got accepted. And if you discuss the time complexity of this problem, so the time complex sorry, the space complexity is actually k. And why is it k? Because initially it was 1, then initially the size of the array was 1, then it got converted to 1 1 1, then it got converted to 1 2 1, and this process goes till we achieve k elements in the vector. Okay, so till we achieve the k elements in the vector. So the maximum number of elements present in the vector is k, hence the space complexity remains k. Okay, so this is the whole idea behind this question. Is it showing like this? Yeah. Okay, so it got submitted and it's 100% faster. So that was about it, and the whole idea was to do it in place to save the to make it more space wise optimal. Okay, so the whole vector is getting converted to k size vector, and we're doing it in place instead of maintaining a two-dimensional array, that is n square space complexity. Okay, so anyone has any doubts regarding this question? fine. Is index current? I'm not sure what this means. I cannot understand. Can you keep your mic a little out from your mouth? Your voice is not clear. It's can you type it out? I understood that as you explained. Okay, okay. Okay, fine. I think that's uh, about the Pascal's triangle question, and it's pretty easy. You have to do it in place. The complexity, space complexity would be O of k. Okay. Let's move on to the next permutation. Now, I know this week has been a little messy for me, so I could prepare these two questions for explanation. Let's move towards the next question, that is next permutation. Okay, basically this Pascal triangle question is a little difficult to visualize, so that's why I had to draw and explain the whole concept. I hope it's clear. And by the way, I'm almost done with the creation of YouTube channel, so I'll be uploading these videos on the channel as well, so that everyone can access it easily. Okay. Uh, all right. Just a minute. Just a minute. Okay, right here we have. Can we zoom a bit? Are we even zooming? Yes, we are. Okay, so the first permutation which we need to do is let me just write some examples, because with that we'll be going through what we need to do is 3 1 3 2. Okay, and we have over here is the next one is 3 2 1. Let's make it a little longer. 4 4 5. Okay, and 5 4 3 2. Okay, over here we have our okay 3 2 1. That's actually fine. The last one was somewhere around here. That is 6214530. 621414530. Is that right? 62154. 62155. Yeah. Okay. Would be okay. Yes, we are ready. Okay. So the one. Let's add one more example. That is simple as 1 comma 2 comma 3. Okay, 1 comma 3 comma no 1 comma 2 comma 3. Okay, so if you look at this example first, what we need to do is we need to achieve the next permutation of this particular array. Okay, that's the whole question about, like, suppose we are over here, the next permutation would be 1 3 2. Now let's just see how we can achieve such permutation. So how this permutation works is, suppose we have this particular array, the next permutation would be something like 1 2 3 and 5 4. Okay, we'll come back to that later on. So our intuition says, the instinct as we look at the question, the first thought which comes us to us is the next permutation should be 132. Okay, so what we basically did is we kept one as it is and we replaced, since this particular position can have two or three. Now if we replace it with three, the leftover value is 2, hence we come out with 132, 1 comma 3 comma 2. Now the question is, why did we replace it over here? Why did we choose 2 as the point to increment or change the value? Why could we could have done with the 1 as well? So, okay, like suppose if this is 1, how about incrementing it to the, or replacing it with the higher value, that is 3, and this will become 2, or this, and this will become 1. This is also a bigger permutation than this because the value 3 is larger, and we know this is the wrong answer is because is because is because replacing this with another value in changes the permutation by a lot, because this is the highest significant bit. What I mean by that, suppose this number consisted of is made of these three numbers, okay, 100, 20 and 3. So if we replace 1 with 3 and we replace 3 with 1, so what we are doing is we are converting this 100 with 300. This 20 remains same, and this 3 will become 1. Yeah. So the sum becomes 3 to 1, and initially the sum was 1, 2, and 3. So this drastically changes because the value at the leftmost position is actually the higher significant bit, which is basically like this is over 3, over here is 300. So to obtain the next permutation, what we must do is, instead of replacing the leftmost position, we must try to replace the which positions which are at the right hand side as much as we can. Okay, because if we do so, we'll be replacing 20 with some other value, suppose maybe okay, like suppose we have okay, yeah, the whole idea is just key, we don't need to um, update the value at the leftmost positions. We need to update the value at the positions which are closest to the rightmost end, so that the resultant sum will be less affected, hence we will be getting the immediate next permutation. Okay, so if we move on to the next example, suppose we have 1 2 3 4 5, we can see that the next position or the next permutation, how this works is since we have 1 2 3 4 5, these will be shuffled among themselves and will generate all possible values, keeping one at constant over here. Okay, so the next will be 2 3 5 and 4. Okay, the next will be 1, maybe what will be next position, 1 2 and okay, what we have here is 1 2 5 3, no, sorry, okay, so 5, and then we have 3 and 5, I guess, yeah, and so on. So ultimately what we are doing is we are shuffling from this value to this value, and we'll be achieving the last possible permutation with 1 at the first position, which will be 5 4 3 and 2. Okay, so if you observe over here, at the very first position was having 2 3 4, the values in increasing order, and if you observe the very last permutation, we have the value at a decreasing order. Okay, decreasing like 5, 4, 3, 2. So that's the whole thing, that when we have a decreasing sequence, that means we are at the very end of the permutation with the first value being fixed to certain value. Okay, and when we have the increasing sequence, we are at the initial position. That's the whole um, idea or intuition behind it. Okay, so what we need to do is we need to check for the decreasing sequence. So because we have the decreasing sequence, that means this is at the very last position, and the next thing which we need to do is and okay, so what comes just right after this? Okay, from here to here we have certain permutations having 1 at the very beginning. What about the next position, next permutation which we can achieve with this? So the obvious answer is to replace this one with higher value. So with what value shall we replace it with? 5 or 4 or 3 or 2? Um, if you replace the 5, it 1 with 5, suppose. So will it be the immediate next permutation? Actually, it won't be, because 5, there are existing values, that is 4 or 3, which are smaller than 5, which will make a smaller permutation rather than replacing it with 5. So what we need to do is we need to find the smallest possible among these integers, which is just greater than 1. Okay, that is the 2 over here. So if you replace 1 with 2, then we will be left out with 1, 3, 4, and 5, and the whole sequence will go again with these value getting shuffled, and hence we will be achieving different permutations with 2 getting fixed at the first position. So that's how the whole permutation works. So the whole idea is to look at the decreasing sequence, which we can say that, okay, yeah, over here we have the decreasing sequence. What we need to do is the element which is not part of the decreasing sequence, we need to replace that to achieve the next permutation. Correct? So far, any doubt? Okay, I guess no. Let's move on to some other example, like just like, okay, so this was covered, and okay, yeah, over here. Okay, so for this example, suppose we are checking the decreasing sequence. So how we're checking the decreasing sequence? We'll be checking from the very leftmost position. Okay, from the very leftmost position, and from the rightmost position, and if we will be checking if the values are increasing. So in this case, suppose in this case itself, in this one over here, the decreasing sequence is still here, and then we achieve a number which is breaking down the decreasing sequence, right? So same concept applies over here. We'll be checking from the rightmost position, and we'll be moving from towards the leftmost position, and and in this particular example, the the pointer will move towards the -1 index, because the whole array is in decreasing sequence. And what does that mean is it means that we have obtained the very last permutation which is possible, because since the whole permutation is basically rearranging these numbers, and the last permutation will obviously contains 5 and others in the decreasing order, right? So same over here, since the elements are 3 to 1, so the last permutation is obviously 3 to 1, because the entire array is in decreasing order. Okay, so for as per the question, if we are given with the decreasing sequence, we'll be returning the initial sequence, because it's like once you achieve initially it started with 1 2 3, right? And the and different permutations in between them uh, are ordered in such in sequentially, like the next one comes as to be 1 3 1 3 2 1 3 2, and then so on till we achieve 3 2 1. Okay, so and after that, if we want to achieve the next permutation, if we are given with this particular uh, permutation, we will be simply returning the first permutation. That's the whole rule which we are given over here. So we'll be checking that later on. Now let's see over here with this last example. How do we do with this particular example? Okay, so like always, we'll be checking out least the decreasing sequence from right to left. So okay, 0 is good. 0, so we are at 0, or we are at actually 3. So we check 3 is greater than 0, good. 5 is greater than 3, good. 4 4 is greater than 5, no it's not. Then this means that this particular index is the one which is breaking the loop, which is breaking the decreasing sequence. Hence what we need to do is we need to take some elements from. Is this the correct example? 1 2 3 4 5 3. Are we missing something? Oh sorry, there's just a slight error. 4 must come before 5, just to take an example. Okay, yeah, so we'll be comparing from the rightmost position. Okay, 3 is greater than 0, good. 4 is greater than 0, 3, good. 5 is greater than 4, and finally we get stuck with 1 that is not greater than 5. Hence this particular element breaks the decreasing sequence. So at this point of time, what we need to do is, like over here, we need to, just like here we replaced 1 with the smallest possible value, that is 2. Over here also we need to replace the 1 with smallest possible, because that is the next immediate sequence which will be generated. All right, just over here like this, all the sequence are starting with 1, then the next sequence which will be starting with 2. Okay, over here also we'll be doing the same. So among these, which is the smallest value? It's 0. But if we replace 0, we'll be achieving the sequence as 5 4 3 and 1, and all the permutation will be um, shuffling of these numbers with 0 at the beginning. But is this the permutation which comes after 1? No, it doesn't, because 0 is smaller than 1. So the whole permutation which comes is basically before this particular permutation. Okay, and yeah, if we are manipulating these particular elements, for sure we are not manipulating these, because just like this will remain same. Okay, all right. So we cannot replace 1 with 0. Cannot replace 1 with 0. So what we will do is we will look for some other element which is slightly greater than 1 but shorter, but the shortest among these. So the next value which comes is 3. Hence we'll be replacing 1 with 3. Okay, so 1 becomes 3 and 3 becomes 1. We will swap basically. Why we are swapping, we are not introducing any other integer like 7 or something, is because we need to attain the permutation using these number only. We cannot use any other number. Hence if we place 3 over here, then it's obvious that 1 will come over here, and we'll be getting the next permutation by shuffling these numbers. Okay, so now we are at this particular position, and since we have these numbers, so what will be the immediate position, immediate next permutation is basically the increasing order, just like I mentioned over here. Over, yeah, when we are starting with this permutation series, okay, you have joined. Anyway, just to, okay, those who have joined just now, I'll be posting the whole video on the group and on our YouTube channel as well. So no issue if you miss some portion. But we're just discussing this next permutation problem. Okay, so in the first, at the very beginning of the permutation, what we observed was we have the whole um, elements in the increasing order, right? And when we achieve at the very end of the permutation of one being fixed, what we have observed, we have the permutation such a way that the elements are in a decreasing order. All right, so to achieve the very next position, or the very next permutation having three fixed over here, what we'll need to do is we need to have these elements in a increasing order, that is a sorted increasing order. So we need to simply sort this particular elements or this range. But hold on, do we need to actually sort this? We don't, because it's just simply in decreasing order. If you see, okay, 5 4 1 0. All right, so since this is in a decreasing order, what we can do is we can just reverse this particular um, array or the subpart. So what will be left out with 6 3 6 2. Let's change the color to maybe brown. Yeah, okay, 6 2 3, and then over here we'll be having 0. That's the reverse of the above subarray. 0 1 4 and 5. That's how we do it. So the entire logic behind this whole next permutation was to first check for any decreasing sequence. Okay, for to check any decreasing sequence from right to left, and once we obtain a particular element like over here 1 that is breaking the decreasing sequence, we swap it with the highest, the number which is slightly higher than the one, that is over here was 3, hence we swap this. Then the last step what we need to do is we need to reverse this, the subarray just right next to what we have swapped. So let's look at the code. This was it. And just before moving toward code, let's take a look at another example, that is 1 5 1 5 6, maybe 3 4, or oh, 2. Okay, suppose we have 2 over here. Okay, yeah, over here the same logic will apply. We'll be looking over the decreasing sequence. Okay, so if we are looking at the decreasing sequence, then the decreasing, this is a decreasing sequence, but we won't be looking at from any random index. We have to look from the leftmost index, rightmost index. Why? Like I explained over here, the it was 100, 20, or just let's do it over here as well. Here only. Okay. So this is basically 1 0 0 0 0 0, that is 5 0 0 0 0, and that is 20006030 and 4. Okay, so this particular layout explains that if we replace the fifth position, if we replace the 5 value or the 2 value or 1 value, what we'll be doing is we'll be changing the value so much drastically that it won't be the we won't be able to achieve the next permutation. Hence, we have to start from the rightmost position and check for that. And to do that, we need to, as per previously explained, we need to check for the decreasing sequence. All right, so decreasing sequence over here will be starting from the very from 3 itself. And why we don't start from 4? Because there's no value behind it, so we start from 3 only. So if we check from 3, 3 is not less than 4, so the decreasing sequence is just 4 itself. Since it is a single number, but the decreasing sequence is just 4. But in our previous example, we had the decreasing sequence 0, 3, 4, and 5. Over here, it's just one single index, so it doesn't matter it has to be large or small. What it needs to be, it can be one element, or it can have two elements, or it can have all the elements. In all the elements, what we need to do, like in this case, oh, come on. Like in this case, 3, 2, 1, we have all the elements in decreasing order. We simply return the first very permutation, that is 1, 2, 3, the initial permutation. Okay, so right here, since this is the decreasing permutation, the next permutation would be replacing this value with immediately higher value, that is only 4 is over here. Suppose there would be present 4, 5, or 2. So in case, we would be replacing it with 4, because that's the just higher than 3. Okay. Yeah, the new guy who joined, no, don't worry, I'll be uploading the recording to in the group. So the last step is, so but over here we only have 4, so we will simply swap 3 with 4, that is 2, 6, 3, 4 and 3. Okay, that's the whole thing. And the remaining thing which is left is to reverse this particular element, that is the subarray. Since this is one element itself, and it will remain same, and this is the final answer. Let's look at the code. Okay, okay, so over here only I wrote, can we have something? I know it's a little messy right here, but I hope it gives the explanation. Okay, let me write once again. Suppose we have 1, okay, then we have 1, 5, 4, 3, and suppose 0. Okay, and we have, so what we need to do is we need to see the decreasing sequence, and then we need to figure out the value which is just higher than 1, and we will be swapping those. Okay, so right here, these are the helper functions which I made myself, and the whole logic is right here. So firstly, if the array is, the size of the array is 0 or 1, that means no element or single element, will simply end the particular function. It will simply return. So the rest of the code is for array having size more than 1, that is 2, 3, 4, and so on. whatever. Okay, so firstly we have our index variable, and this is for just uh, figuring out the position which is breaking the decreasing sequence. Okay, so initially it is set as -1, that is just behind the zeroth index position. Okay, zeroth index right over, is there any other color? Yeah, over here, this one. Should I put this? Yeah, so this is the zeroth index, this is the zeroth index, this is the -1 index. Okay, so our for loop runs from this position, from this position towards the position till we achieve the element breaking the decreasing sequence. Okay, so once we achieve an element that is the current element, that is, suppose we are at 3, we're checking 3 must be greater than the next element, that is, okay, so I is pointing towards this over here, I is pointing towards 3. Now 3 must, if 3 is less than the value next to 3, that is 0, which is not, hence this will not enter. So this whole condition will break when our pointer will reach towards at 1. So 1 is less than 5, hence this particular if statement will execute. So basically the whole execution of this statement is when we figure out an element that is smaller than the next element, and at that point of time we'll store the index, store the value of I in the index variable, and that will be basically denoting the element which we need to change. Okay, and if there is no particular I that is satisfying this if condition, suppose if it doesn't gets inside, the index will remain -1. All right, the for the case of for the case of 3 2 1, the entire sequence is in decreasing order, right? So the index will remain -1, and the whole index will remain -1 even after iterating through this for loop. So at last what we will do is, if the index is -1, okay, if the index is not -1, so if the index is -1, we'll be just simply reversing the whole array. Okay, so 3 to 1 will become 1 1 2 3, and we'll return it. Okay, that's the whole idea if it is -1, and if it's not -1, then we'll do this particular approach, that is replacing it the current, the just higher value. So swapping the value, right? So swapping value is okay, so this is the function which I have written. So swap function takes two values, that is first value and the second value which needs to be swapped. So the second value is right here, that is nums inside bracket is this particular function, that is find position. Okay, so the whole thing which find position does is finding the position which needs to be swapped with this. Okay, so the find position takes num vector as input, then a key value, that is 1, and start and last, that is 5 and 0, because we know that the index is at 0th position, so the start value is 1. So the start value is 1, and the end value is 1 2 3 4, 1 2 3 1 2 3, okay, and 4, so the last value is 4. So it will iterate through it, and whenever it finds a value just slightly greater than 1, then it will return that value, and the whole function will be basically returning the value, that is the third. Okay, these two values are same, but this 3 indicates the index and this 3 indicates the value. Okay, so the whole find position function returns a value 3, hence num of 3 is 3 and num of index is 1. We'll replace that we'll swap that those two values, and after swapping those two values we will be getting as 3. Okay, we'll be getting as 3, 5, 4, 1 and 0. Notice how after swapping these two values we achieve with a reverse order or decreasing order sequence. It's very obvious why, because 0 is smaller than 1 and 4 is larger than 3. Okay, so if you replace 1 over here, 4 will obviously larger than 1 and 0 will obviously smaller than, I mean, swapping does, and it does ensure that the sequence will be in decreasing order, hence we don't have to worry about sorting it out. Okay, so simple reverse statement will work, reverse function will work, and I made a function right here. So this is just swapping the elements. Okay, like swap this, and hence we'll be achieving 0, 1, 4 and 5. Simple. Okay, so the whole idea is over here. What we did was we found out the index that is breaking the decreasing sequence from this for loop, and if the index is other than 1 we have to find out the position which is just greater than the particular index and swap those values, and if and then we will have to reverse the vector. Okay, so reversing vector works in both of the case if the index is -1 or 0. The only difference is we need to swap when we figure out if the index exists in the particular array. Okay, and it's not -1. That was it. And the complexity of this problem would be O of n. Why? Because so though we are doing two things. Okay, so first we are finding out the index that is breaking the sequence, and then we are swapping those two values, and finally we're reversing. So finding out the index is just iterating through one iterating one time, and we'll be figuring out the value which is breaking the loop, breaking the decreasing sequence. Hence this particular code takes O of n. All right, because it's iterating once. And what about swapping? It takes nearly O of 1 time complexity. And what about reversing? It also takes only one, not one, O of n. The complexity is O of n. Why? Because just like we are swapping 0 with, like, it's obvious, like replacing the n value with the first value, then the second value with the third value. We are when we are replacing two values, or we are swapping the two values, we are not coming to those value again. All right. So in just to clear it out why this is, let's make the example a little longer. 5, 4, 3, 2, 1. Okay, so once we replace 6 with 1, we are changing this value to 1 and we are changing this value to 6, and after this we are not observing these two elements. We move on to the next two elements and we see 5 and 2, and we swap these values. We swap 5 and 2. Okay, so we are not observing the already swapped elements again. Hence, every element is observed only once, and the total number of elements are n. Hence we are observing every element once. Hence, the complexity turns out to be O of n. So the space complexity is O of 1 as well, because we are not using any extra space. We are doing in place. We are checking out everything in place, and that's how this question is done. And just to see if this works or not, we will. I initially got wrong answer and runtime error. I made few minor mistakes anyway. So this question is submitted, got accepted. Any question till now? Do you have any? Do you have any questions? Do you really think we need to change the format of discussion, or is it even? Um, okay, she left. No issue. Just a second. Okay, it's too late. I know it's 11 p.m., but since we had to do, I mean, let's not break the protocol of doing discussions at the weekends. So I just explained it. Even if people don't attend the session, I will be uploading this particular recording on YouTube. So if anyone has any doubt, they can comment it over there. But at least we need two or three people who are in the session so that hmm, I have someone to interact with. Anyway, so I was supposed to explain these two questions. Do you have any other questions you need to get cleared? Because I will not go into detail, but I can roughly explain game of life or search a 2D matrix question and yeah, or rotate matrix question. Do you need a small explanation? Squared algo, squared algo. Which question are you talking about? Square root algo. Are you talking about week 3? This one. I didn't get what you are trying to say with this statement. Okay. In week 2, do you have any other? I can explain game of life. I can explain this. Such a 2D matrix. Such a 2D matrix. Matrix 2 question. In a brief. Square root decomposition, just an algo. I am having some problem. Square root decomposition, just an algo. Are you talking about this particular question? This one? Square root decomposition. I mean, is the question in the roadmap or you're just talking random? Okay, fine. Anyway, even if you have any doubts regarding lore, you can't solve any problems. Okay, suppose we are in week 2 section, week 2. Okay, so there are editorials and there's a practice section. You, if you can't solve any particular problem, like suppose you can't solve any spiral matrix problem, you can go on to the solution section and you can look on to the question, that is whatever question you have doubt in. Suppose this one or this one, any question. Okay, I have provided links to solutions to each question. So I only collect those questions in of which I can find any solution. Video explanation. All right. So the editorials, I have attached different explanations, and the problem and the practice sections also have solution links, so you can refer to them. Okay, yeah, so a random question. Okay, you can, I mean, see another YouTube video or something, because the scope of this discussion is just to cover the questions of the roadmap. Okay, I think that's pretty much it. Let's end the meeting. and see you next weekend. It's really nice that you have joined. Okay, then bye bye. Good night. See you.